Absolutely, there is life elsewhere, and almost certainly, intelligent life. It has to be, the odds are just overwhelming. Voyager 1 has been our silent ambassador to the stars for decades, and now the stars have responded. According to Bill Nye, the Voyager missions were a testament to human curiosity and ingenuity, pushing the limits of our exploration and understanding for over 4 decades. The spacecraft had faithfully sent data back to Earth, exploring the outer planets and venturing into interstellar space. Yet, their mission had always been a one-way street, a broadcast from us to the universe. That is, until now. A response has been received by Voyager 1, a sophisticated, purposeful message from the unknown. What could it mean? Is this an ordinary cosmic noise or random fluctuation, or is it a reply or something beyond human understanding? Join us as we explore how Voyager 1 just received a disturbing reply in deep space. Launched in 1977 alongside its twin, Voyager 2, these probes were humanity's first interstellar messengers, carrying the Golden Record, a time capsule intended to communicate the story of our world to extraterrestrials. Now, Voyager 1 has pierced the veil of the cosmos, and the universe has answered back. As Bill Nye says, humanity is on the brink of a revelation that could alter the course of history. Ever since humans acknowledged the enormity of the universe, we have intuited that life must exist somewhere, either in our galaxy or some galaxy far, far away. Given that the universe has billions of galaxies, each containing billions of stars, and that a small fraction of those stars include planets comparable to Earth, it is reasonable to assume that there exist hundreds, if not thousands, of extraterrestrial civilizations. Even more liberal was Carl Sagan, a prominent figure in the SETI movement until his death in 1996, who proposed the possibility of 1 million civilizations in the galaxy. That's a lot of extraterrestrials. It is easy to see why astronomers in the 1960s were so hopeful as they set out on their never-ending search for extraterrestrial life. Researchers from SETI embarked on a quest to discover extraterrestrial intelligence after estimating the number of communicative civilizations in our galaxy. 2 primary choices were available to them: communicating in person or over long distances. For the first one to work, either aliens or humans would have to go to the other side of the universe. Given the vast distances between our solar system and other Milky Way stars, this appeared extremely implausible. Radio transmissions, which include the transmission and reception of electromagnetic signals via space, were part of the second scenario. A 210-byte message was purposefully delivered from Puerto Rico's Arecibo Observatory to the globular star cluster M13 in 1974 by astronomers who hoped to signal a civilization there. Data like the molecular formula of DNA and the atomic numbers of important elements were included in the message, which included basic information about ourselves and our place in the cosmos. However, there hasn't been much of this kind of proactive dialogue. The majority of astronomers' communication strategy is based on passive listening for broadcasts sent by extraterrestrial civilizations. For these kinds of listening tests, a radio telescope is ideal since it can pick up energy waves that are too long for optical telescopes to see. Radio astronomy involves directing a massive antenna toward a nearby star that resembles the Sun and adjusting its frequency to focus on the microwave part of the electromagnetic spectrum. Due to its lower noise floor, the microwave frequency band, which spans 1000 to 3000 MHz, is perfect for this application. Additionally, it has an emission line at 1420 MHz, which scientists have identified as a hiss that echoes throughout the galaxy. Neutral hydrogen undergoes energy changes along this narrow line. Hydrogen is a perfect identifier because all cosmic civilizations should be aware of it as a primal element of the universe. Since 1960, a number of international teams have been methodically surveying the Milky Way and other galaxies for stellar signals. As we continue to explore the planets beyond our solar system, the Voyager 1 spacecraft has played an essential role that no one could have foreseen 47 years ago. Even after all this time, the probe is still sending data about its travels back to Earth, so it must be doing something right. The communication from Voyager ushers in an uncertain but potentially rewarding future. The Voyager missions took advantage of a special alignment of the outer planets that happens just once every 176 years. This alignment allows spacecraft to gravitationally slingshot from one planet to the next, making the most efficient use of their limited fuel. Spacecraft from NASA were initially intended to travel beyond Pluto, Saturn, and Jupiter, while other probes were to travel past Uranus and Neptune. Even though NASA had to cut back on its intentions because of budget constraints, the two Voyager spacecraft it launched were nevertheless quite useful. As Voyager 2 soared beyond Jupiter and Saturn, it also passed Uranus and Neptune, whereas Voyager 1 was laser-focused on those two planets. 2 golden records were approved to be installed on board the Voyagers by NASA, who recognized that the spacecraft would eventually go to interstellar space. Sounds ranging from whale calls to the music of Chuck Berry were placed on board, as well as spoken greetings in 55 languages, in case aliens ever happened upon the spacecraft and were curious about their origins. The 12-inch wide gold-plated copper discs also had schematics illustrating how to operate them and the Sun's location relative to nearby pulsars, a sort of neutron star. A trio of radioisotope thermoelectric generators, which transform the thermal energy emitted by plutonium's radioactive disintegration into usable electricity, power the two spacecraft. A magnetometer, a 2-camera imaging system, various spectrometers, and equipment to detect low-energy charged particles and high-energy cosmic rays were among the 10 scientific instruments attached to the probes. There have been a total of 11 scientific investigations conducted aboard each Voyager by using the communication system to learn more about the planets and moons. On September 5, 1977, during launch, the Voyager 1 spacecraft almost never lifted off because the rocket almost ran out of fuel. Nevertheless, the probe swiftly surpassed its identical twin and departed from the primary asteroid belt spanning Jupiter and Mars. Prior to Voyager 2's ability to re-establish contact at a distance of 165 million miles from Earth, the Voyager 1 spacecraft transmitted its initial images of Jupiter to Earth in April 1978. In March 1979, Voyager 1 surprised NASA by detecting a tiny ring encircling the massive planet. 2 other moons were also discovered. The large Galilean moons of Jupiter, Io, Europa, Ganymede, and Callisto, and Amalthea were also captured in great detail by Voyager 1. In the same vein as its predecessor, the Pioneer spacecraft, Voyager 2 found that the moons of Jupiter were dynamic, independent worlds. Intriguing new information regarding these naturally occurring satellites was also uncovered by Voyager 1. As an example, the fact that Io is mottled with yellow, brown, and orange and has numerous volcanoes demonstrates that moons similar to planets can have dynamic interiors. In addition, images of Europa returned by Voyager 1 revealed a mostly flat surface with lines running across it, suggesting the presence of ice and possibly an ocean beneath it. A large subterranean ocean of liquid water, possibly capable of supporting life similar to that on Earth, is probably harbored by Europa according to subsequent observations and analyses. On March 5, 1979, Voyager 1 approached Jupiter within 174,000 miles, passing near the tumultuous cloud tops. The probe's next target was Saturn. The only year that scientists had to wait to capture close-up images of Saturn was 1980. Surprisingly, the ringed planet was just as full of surprises as Jupiter. One of Voyager 1's targets was the F-ring, a thin structure discovered only the year previously by NASA's Pioneer 11 probe. Voyager's high-resolution camera spotted 2 new moons, Prometheus and Pandora, whose orbits keep the icy material in the F-ring in a defined orbit. It also discovered Atlas, a new ring, the G-ring, and took images of several other Saturn moons. Voyager 1's primary mission came to a close with the Saturn encounter. Following that, attention turned to keeping tabs on the spacecraft as it raced toward interstellar space. Weighing 1,590 pounds, Voyager 1 captured one of the most famous images in spaceflight history 20 years before it achieved that feat on February 14, 1990. The probe turned back toward Earth and captured the pale blue dot image, showing Earth as a tiny speck in the vastness of space. This iconic image reminded humanity of its small place in the universe and underscored the importance of our ongoing search for life beyond our planet. In 1990, Voyager 1 snapped an image of its home planet from 3.7 billion miles away. This iconic photo shows Earth as a tiny dot suspended in a ray of sunlight, known as the pale blue dot photograph. Among the hundreds of other images taken that day by Voyager 1, which included the Sun, 5 other planets, and a multi-image solar system family portrait, this photo stands out. It serves as a constant reminder that Earth is a minuscule speck in an infinitely vast and unfathomably massive universe. In August 2012, Voyager 1 ventured into interstellar space, leaving behind the heliosphere, the enormous bubble of charged particles that the Sun blows around itself. This discovery was made after a powerful solar eruption was recorded by Voyager 1's plasma wave instrument between April 9 and May 22, 2013. The eruption caused electrons near Voyager 1 to vibrate, and from these oscillations, researchers discovered that Voyager 1's surroundings had a higher density than what is found just inside the heliosphere. It seems paradoxical that electron density is higher in interstellar space than it is in the Sun's neighborhood. However, researchers explained that at the edge of the heliosphere, the electron density is dramatically low compared with locations near Earth. After retracing their steps through Voyager 1's records, scientists finally pinpointed August 25, 2012, as the formal departure date from the heliosphere. The electron oscillations in the spacecraft's readings of charged solar particles both contributed to fixing the date. On that fateful day, which coincided with the death of Apollo 11 astronaut Neil Armstrong, the spacecraft detected an increase of 9% in galactic cosmic rays, which originate from beyond our solar system, and a dramatic decrease in these particles. At that point, Voyager 1 was 11.25 billion miles from the Sun. Voyager 1 has been sending back a wealth of useful information about the interstellar medium ever since it soared into orbit. Among its many findings are proof of extremely high levels of cosmic radiation and evidence of the interaction between charged particles generated by stars and those originating from the Sun. Engineers are still in awe of the spacecraft's capabilities. For instance, in December 2017, NASA declared that Voyager 1 had effectively oriented itself to communicate with Earth using its backup thrusters. The last time the trajectory correction maneuver thrusters were activated was during the flyby of Saturn in November 1980. From that point on, the spacecraft's usual attitude control thrusters became the primary means of guiding it into an optimal communication position with Earth. However, as the attitude control thrusters started to fail, NASA opted to try out the trajectory correction maneuver thrusters, which could extend Voyager 1's operational life. That test was successful. To preserve Voyager 1's limited power supply, several measures have been taken. For instance, the cameras on board were disabled not long after the pale blue dot photo was captured, since the cameras couldn't capture much light in space. Additionally, 5 scientific instruments have been disabled. In November of the previous year, Voyager 1 stopped transmitting data to Earth, suggesting that it was not collecting any engineering or scientific information. Fixing the fault of the universe's most isolated spacecraft isn't simple. Problems arose for NASA when the probe suddenly stopped relaying data on the interstellar medium. Commands transmitted from mission controllers take 22.5 hours to reach the small probe, and the engineering crew must wait the same period again for a response due to the spacecraft's distance of 15 billion miles, traveling at 32,000 miles per hour. Over 5 months, NASA worked on the issue. In March, they sent a command to the spacecraft to relay a full memory readout back to Earth, emphasizing any malfunctioning components. The Flight Data Subsystem, one of Voyager's 3 onboard computers responsible for packaging data before sending it to Earth, was found to be producing repeating gibberish due to a malfunction. Since the broken chip couldn't be replaced, NASA had to creatively find a different space in the Flight Data Subsystem memory to store the troublesome code. They divided the affected code into smaller pieces and moved them into the computer's memory. The Jet Propulsion Laboratory of NASA officially declared that Voyager was back in service following this remarkable long-range software update. We now eagerly await the influx of Voyager 1 scientific data in the upcoming weeks. It is unclear what caused the chip to malfunction, but the team is considering the possibility that it was damaged by an energetic particle from space or just became worn out after 47 years. It's also unclear to NASA if this malfunction was a solar or interstellar occurrence. Meanwhile, humans have purposefully transmitted multiple powerful signals into space, hoping to be picked up by alien civilizations. Some interesting and mysterious signals, such as the WOW signal, have been received from space. In 1973, the Ohio State University Radio Observatory, known as Big Ear, began scanning the skies for traces of extraterrestrial transmissions. On an August night in 1977, they received an astonishing signal that wasn't a whimper but a roar. The data generated by the telescope was not new to Jerry Ehrman, a professor from Ohio State who volunteered with the Big Ear SETI program. Ehrman, tasked with sifting through the monotonous data, discovered a sequence indicating a radio transmission 30 times louder than the ambient noise in space. Excitedly, he scrawled, "Wow," next to the cryptic sequence 6EQUJ5, marking the momentous discovery. Still, after all this time, the so-called wow signal is the closest encounter humans have had with potential alien intelligence. Although the intense radio wave burst only lasted 72 seconds, many amateur SETI enthusiasts and astronomers attribute its unusual properties to a spacecraft. To what end remains a mystery, but the search for extraterrestrial intelligence continues. Does the wow signal seem to be a message from another world? Many astronomers have considered this possibility. The signal, almost exactly matching the electromagnetic wavelength of hydrogen, was captured at a frequency of 1420.456 MHz. The SETI team concluded that this particular frequency would be optimal for interstellar communication. Another distinguishing element of the wow signal is its shape. When plotted against time, the signal initially registered as a 6 on the telescope's loudness scale and then changed to an E. The computer displayed letters when the number exceeded 9, and the signal gradually dropped back down to 5 after reaching its peak at U, equivalent to 30 on the loudness scale. This created an almost symmetrical pyramid structure on the graph. Sharpness is another interesting aspect of the wow signal. Natural radio wave sources, such as stars and galaxies, typically generate waves across a wide frequency spectrum. In contrast, the wow signal was so narrow that it had to have been created by an artificial transmitter, either by humans or intelligent beings from another planet. The signal originated from a region of the sky close to the constellation Sagittarius, which points toward the galactic center. This area, dense with stars, would be an obvious choice for an extraterrestrial civilization attempting to contact another sentient species. The fact that no one has managed to reproduce the wow signal is a compelling argument against its extraterrestrial origins. Many possible earthly explanations exist, such as a reflection of a terrestrial radio signal bouncing off space debris or a transmission from a secret military satellite. It could also have been a glitch in the Big Ear's computer system. Another argument against the wow signal's extraterrestrial origins is its short duration. If an alien civilization were trying to get our attention, why would they send a message that lasted only 72 seconds and was never repeated? Additionally, some experts argue that the signal's power is too great to have originated from even the most advanced extraterrestrial civilizations, according to the Kardashev scale. The wow signal remains one of the biggest riddles in the search for extraterrestrial intelligence. Recently, a cosmic object has been pulsing radio waves toward Earth every 22 minutes for more than 30 years, leaving scientists baffled. Thought to be a dying star emitting energy from its poles, this object, named GPM J1839-10, stands out due to its exceptionally slow speed and consistent behavior. Astronomers usually see recurring radio signals in space that go on and off at faster intervals. Neutron stars, very dense celestial bodies, emit dazzling rays of light and energy from their magnetic poles, similar to a lighthouse beam sweeping across a boat. These blips were initially believed to be messages from extraterrestrial beings. Researchers anticipate that pulsing neutron stars will gradually decrease in speed until they encounter a theoretical limit called the death line, beyond which the stars will collapse due to insufficient mass. GPM J1839-10's pulses, occurring every 22 minutes and lasting up to 5 minutes, defy expectations. This isn't the first super-slow object discovered, another object pulsed every 18 minutes. The source of these beams is hypothesized to be a magnetar, a neutron star with extremely strong magnetic fields. GPM J1839-10, however, possesses an additional surprise: its pulses have been picked up unnoticed by observatories worldwide for years, beaming like clockwork every 1118.957 seconds. This defies what we know about neutron stars, which are expected to die out in months. Despite these challenges, Voyager 1 and Voyager 2 will continue to drift through the galaxy, carrying golden records with information about humanity, acting as interstellar messages for potential intelligent life. The Voyager's continuous broadcasting of Earth's coordinates raises concerns about the potential dangers of openly announcing our location. The science fiction novel, Battlefield Earth, by L. Ron Hubbard suggests that doing so could attract hostile extraterrestrials. Although pinpointing Earth's location on the Voyager records was brilliant, its flaws mean that anyone receiving it might not be able to pinpoint our planet's exact location. Nonetheless, the Voyager spacecraft remain out there, and the possibility of an alien race discovering them still exists. Thanks for watching another episode of Voyager. While you're here, click on the video on your screen for more mind-blowing content about space.